The atmosphere is divided into four main layers, distinct from each other due to major changes in temperature. These are the troposphere, that we live in, near the surface of the Earth, the stratosphere, that houses the ozone layer, the mesosphere, a cold layer lower in density, comprising about 0.1% of the atmosphere, and the thermosphere, the top layer, where the air is hot but very thin. The troposphere is the lowest region of the atmosphere. This region of the Earth's atmosphere contains about 75% of the atmosphere mass and 99% of the total mass of the Earth's water vapor. The average height of the troposphere on Earth is 13 kilometers, varying based on the latitude of the Earth. Temperature in the troposphere generally decreases with height, decreasing approximately 6.4 degrees Celsius for each kilometer of altitude. Carbon dioxide is present in small amounts in this region. However, its concentration has nearly doubled since 1990. It is a key concern that the increase of carbon dioxide could cause significant changes to the world's weather patterns and climate. The boundary between the stratosphere and the troposphere is called the Tropopause, which has an average altitude of 9 kilometers over the polar regions and 17 kilometers above the equator. The Tropopause is the point where air ceases to cool with height and becomes almost completely dry. More formally, the Tropopause is the region of the atmosphere where the environmental lapse rate changes from positive as it halves in the troposphere. The jet stream sits at this level, and it marks the highest point at which weather can occur, which will be expanded upon later. Despite the lack of weather occurring in this area, it is possible for thunderstorms, particularly in the tropical regions, to enter the lower tropopause. This is often referred to as an overshooting top. When this occurs for a period longer than 10 minutes, it is a strong indication of a severe storm. These storms can result in low-frequency vertical oscillation, which can result in gravity waves that affect atmospheric and oceanic currents. Above the tropopause lies the stratosphere. The stratosphere is stratified, meaning it contains different layers of temperature. As the altitude increases, the temperature increases, as a result of the absorption of the sun's ultraviolet radiation by the ozone layer. As previously mentioned, the stratosphere houses the ozone layer, which protects the Earth from the effects of radiation. Anthropogenic activities over time have resulted in the depletion of ozone in the upper atmosphere. There is a boundary between the stratosphere and the mesosphere, known as the stratopause, found approximately 50 kilometers above the Earth's surface. The stratopause is the region where maximum temperature of minus 15 degrees occurs. The mesosphere is the third highest layer of the atmosphere and occupies the region above the stratosphere and below the thermosphere. This layer extends from the stratopause at an altitude of approximately 160,000 feet to the mesopause at approximately 260,000 feet above sea level. Temperatures drop with increasing altitude to the mesopause. That marks the top of this middle layer of the atmosphere. It is the coldest place on Earth and has a temperature of around 120 degrees Fahrenheit. The temperature decreases with height at a rate of approximately 3 degrees per kilometer. The temperature decrease is the result of decreasing absorption of solar radiation by the atmosphere and increasing CO2 cooling. The concentration of nitrogen and oxygen is 1,000 times less in this region than the troposphere. Just below the mesopause, the air is so cold that even the very scarce water vapor at this altitude can be sublimated into polar mesospheric noctilucent clouds. These are the highest clouds in the atmosphere and may be visible to the naked eye even if sunlight reflects off them approximately an hour or two after sunset, or a similar length of time before sunrise. They are most readily available when the sun is around 4 to 16 degrees below the horizon. The mesosphere is also the layer where most meteors burn up upon atmospheric entrance. The thermosphere is the second highest layer of the Earth's atmosphere and extends from the mesopause at an altitude of approximately 260 feet up to the thermopause, at an altitude that ranges from 1.6 million to 3.3 million. In the thermosphere, the temperature increases to reach the maximum values that are strongly dependent on the level of solar activity. The temperature of the thermosphere gradually increases with height. The layer is cloudless and devoid of water vapor. The uneven distribution of radiative heating in the Earth's system produces a meridional circulation of air, with rising motion at low latitudes and sinking motion at mid and high latitudes. The meridional overturning of air masses is modified substantially by the Earth's rotation, especially outside the tropics, where the mean circulation is nearly circumpolar. The flow of air is impeded by features on the Earth's surface, such as mountains, and the heat release associated with the formation of clouds, as well as weather systems in the troposphere. The height of the thermopause varies considerably due to changes in solar activity. Because the thermopause lies at the lower boundary of the exosphere, it is also referred to as the exobase. The lower part of the thermosphere, from 260,000 to 1.8 million feet above the surface of the Earth, contains the ionosphere. The ionosphere is a region of the atmosphere that is ionized by solar radiation and is responsible for auroras, such as the aurora borealis. Though there is no definite boundary, the Kármán line is generally considered the border between the Earth's atmosphere and outer space. The region above the thermosphere is the exosphere, where the Earth's atmosphere transitions into space. This is the point which marks the end of the Earth's atmosphere, where outer space starts. The exosphere is the outermost layer of the Earth's atmosphere, and extends from the exobase, which is located at the top of the thermosphere. In Earth's atmosphere, the exosphere is the highest part of the atmosphere, where the density of gas molecules is very low. The climate is the average weather of an area. Based on the position of the Earth, the weather across the Earth changes. Weather is the state of the atmosphere at any given time and place, with respect to variables such as temperature, moisture, wind velocity, and pressure. Climate is the composite or generally prevailing weather conditions of a region. Jet streams are meandering bands of fast winds located near the tropopause that act as driving factors for weather in the mid-latitudes. The jet stream is a strong core of winds, around 5 to 7 miles above the Earth's surface, blowing from west to east. The speeds of these winds can exceed 200 miles per hour, helping develop and steer weather in the globe. The change in wind pressure caused by the jet stream affects conditions on the lower level, such as areas of high and low pressure. The jet stream varies in speed and trajectory. The jet stream can influence the strength of an area of low pressure, generally leading to stronger winds and potentially stronger storms. In contrast, slower jet streams can cause areas of high pressure, resulting in less stormy weather conditions. Atmospheric blocking due to persistent meandering of jet streams often causes weather extremes in the mid-latitudes. Temperature and rainfall are intimately linked with jet stream changes. The jet stream is a key component of global warming. The study on screen shows that rising greenhouse gas concentrations are causing the warming of the Arctic regions and increasing the frequency of extreme weather events. The Arctic lower atmosphere has warmed more rapidly than that of the globe as a whole. This has been accompanied by an unprecedented seamelt. The Hadley cell is characterized by low-altitude air movement towards the equator, with heating that rises vertically, with poleward movement in the upper atmosphere. This forms a convection cell that dominated tropical and subtropical climates. Linking back to climate change, it is believed that the Hadley cell has strengthened in recent decades. Observations show that it has widened between 2 and 5 degrees since 1979. It is a key concern, as discussed in the paper on screen, that this could cause drier weather in northern regions. Consistent evidence has been found for the intensification of the Hadley cell since 1950. In summer, the Hadley cell reaches higher latitudes than in winter, since the summer cell deviates more from the angular momentum conserving state, resulting in weaker upper-level zonal winds, which enables the Hadley cell to expand further poleward, becoming more unstable. Projections of the 21st century climate suggest the poleward expansion of the Hadley cell will cause subtropical dry zones in response to the increasing levels of greenhouse gases. The Ferrel cell is a mid-latitude atmospheric circulation cell. In this cell, air flows poleward and eastward, near the surface and towards the equator at higher levels. Changes in European storm activity caused an intensification and northward shift in the Ferrel cell that leads to warming over a broad region of Eurasia. In the polar cell, air rises, diverges, and travels towards the poles. Once over the poles, the air sinks, forming the polar highs. The polar highs are areas of high atmospheric pressure around the north and south poles. The north polar high is stronger because land gains and loses heat more effectively than in the sea. In the polar cell, at the surface, air diverges outwards from the polar highs. Surface winds in the polar cell are easterly. At this point it should be noted that low pressure systems are usually associated with clouds and precipitation, whereas high pressure systems are usually associated with clear skies, dry weather, and greater diurnal temperature changes from day to night. A weather front is a boundary separating two air masses that differ in density. These play a large role in weather. When a weather front passes over an area, it means a change in weather, such as rain or wind. Horizontal temperature gradients are commonly used to define the fronts and are shown on weather maps as cold and warm and stationary fronts. As a brief note, clouds form wherever air is cooled below its dew point, whether by radiation, by mixing with cooler air, or by ascent in the atmosphere with resultant decompression. There are several different species of clouds, a key one being cirrus clouds, which play a key role in regulating outgoing long-wave radiation. North Atlantic Oscillation is a vital component in the development of weather systems. The North Atlantic Oscillation is a large-scale alternation of atmospheric mass between the subtropical high surface pressure centered on the Azores and the subpolar low pressure systems centered on Iceland. The NAO describes the speed and direction of the westerly winds across the North Atlantic, as well as the winter sea surface temperature. The NAO is associated with changes in wind strength and direction, heat and moisture transport, and the frequency and strength of storms. A high index year of NAO leads to increased westerlies, causing cool summers and wet winters in Eastern Europe. If the NAO index is low, westerly winds are suppressed, leading to cold, dry winters, bringing increased. Milankovitch cycles describe the collective effects of changes in the Earth's movements on its climate over thousands of years. Milankovitch Theory describes the collective effects of changes in the Earth's movements upon its climate. Milankovitch mathematically theorized that variation in eccentricity, axial tilt, and precession of the Earth's orbit determined climatic patterns on the Earth through orbital forcing. El Nino is defined as an anomalous warning of sea surface temperatures of approximately 2 degrees or more in the central and eastern Pacific Ocean of the southern hemisphere. El Nino Southern Oscillation is a climate event that originates in the Pacific Ocean but has wide-ranging consequences for weather around the world, and is especially associated with droughts and floods. El Nino refers to the exceptionally warm sea temperatures in the tropical Pacific, but it is linked to major changes in the atmosphere through the phenomenon known as Southern Oscillation, so that the whole phenomenon is called El Nino Southern Oscillation by scientists. This arises because of the coupled atmosphere-ocean interactions whereby winds create changes in sea temperature that in turn determine where the main tropical convection and storm activity occur, and thus determine the winds.